His computer. Good. Yes, so I was saying that we have come a long way to be where we are at today. And so we are almost done with networking. And we are in the second last topic. So we are going to be talking about additional networking protocols. And we have a lab that we will be doing together. So we will do this lab as part of the teaching, so that when you guys go into your groups, you'll now be able to do that lab with ease. I hope that one makes sense. And then I'll also leave this KC for you guys to do in your labs, in your groups, in your groups. And then as you can see, tomorrow's topic, additional networking technologies, we only have a KC, we don't have a lab. We only have a KC, there's no lab that accompanies that. And then of interest also is for you guys to understand the VPC, the topic on VPC, because this is very, very important. And then there's a lab that follows, actually two labs that follow. One is to create subnets in VPC, and is also to create networking resources for a VPC. So we are hoping that when you guys go into your lab, when you go into your groups, aside from doing this, at least try and see if you can do one of these. And then of course, tomorrow in the afternoon, you guys will now be able to do all the other pending networking labs, because we've just created that specific session for you. Additionally, we have agreed together with Instructor Joy that we are not going to, I'm still on, that we are not going to have an assessment for networking. Instead, we will record your labs. We will record your labs as part of the assessment. So that is why we are insisting that you finish your labs. We are insisting that you finish your labs tomorrow. So by tomorrow, 6 p.m., we'll be checking to see who has not finished their labs and why have you not finished. So make sure that you finish your labs. So we will capture that as part of your assessment. So I was hoping to see people clap or people even react with happiness that you'll not be having assessments. Or you want us to set something small for you guys to do a bit of IP subnetting. You show us how you know how to subtract and divide those numbers. Do you want that? Do you want that? Nobody is reacting. Hey, teaching afternoon classes can be a drag, I tell you. Teaching afternoon classes can be a drag. Hey, you, Mark, see, I've just explained. And you asked a question and then disappeared and then came back 5 minutes later to re-ask the same question. Mark.
So I am having some network connections. Problem, I mean, sorry.
So your network is not networking. Okay, no worries, no worries. Interesting. It's doing that when we are doing a course on networking. So I was saying that there is a new form that you guys are supposed to be filling. You're supposed to be filling that form just to tell us that you will not attend class. There's a form that you are supposed to be filling. And let me see, where is that form? Is it opened? On which browser is it opened? Just a second. There is a form that you guys are supposed to be filling to tell us that you will not be attending class. And it is mandatory that you fill it. And this is how mandatory it is. If you fail to fill it and then you are absent, it is there are high chances that you will be dropped without any further communication, because it shows lack of speaking from your side, which is not good. Communication is two-way. So, good. There it is. There it is. There it is. So Joy has shared it in the chat. Joy has shared it in the chat, and that is awesome. She has shared it in the chat. Joy, kindly share the same because the main group here, AWS Restart, that has both channels in it, so that they can also access it in subsequent days. Thank you for that, Joy. So that is good. Clinton, when you are planning to absent yourself from class?
Clinton, are you serious?
Let me just laugh. Clinton, you please understand. Listen again. I'm saying you only fill that form to tell us that you will not be in class. Not that you have been in class, that you will not be in class, Clinton. Does it make? Clinton, in a make?
Kati ameshajaza.
Yes, iko sawa. Najaza sahi.
Mm. So see, just if you are in class, you only just it when you are not coming to class, please. So
Oh, if you are present, you don't nini.
yeah,
don't
if you are present,
see
you don't jaza. You know, even the title itself. What does it say? What does it? What does the form say? Let me just click on that link. I think my copy. So the title in itself, I think this is important. Let us just see it. I don't mind it being captured in the recording because someone missed class will see it. So Lanley Africa, class absence and time off form. You understand? Simone your title. Class absence. Clinton, mone yo.
Yes, ndo naona. Sikuwa
yes.
najua. I thought you were supposed to feel whether present or absent.
For class presence, there is an attendance sheet that we normally fill ourselves as your instructors to mark you present or absent. So if you are present, we'll mark you present there. That is sufficient. Then if you are absent, you fill this, and then we also mark you absent. And then now when we are looking at you being absent, we can now go back to this form and say, you are absent on this day because of A, B, C, D. You understand, Linton?
Yes. Okay, thank you.
Good. Most welcome. That aside, okay. So that aside. So I was saying that today we are going to do our second last topic, which is additional networking protocol. And then I think you're really going to enjoy this because it's actually like a summary of what we have done before. You'll hear the same things that we've talked about before. Sometimes repetition is good because it's repetition for emphasis, so that things just get to settle. And then we'll be doing this lab. And before even we do this lab, we'll talk a bit about VPC because Joy took us through VPC, and I believe that right now you guys understand what VPC is, what VPC can do. And you will see, we are hoping that maybe by the end of networking, you guys will be so confident handling matters to do with VPC and EC2. EC2 is the server that we've been using doing the other labs, and now it is to be used now in collaboration with the VPC. In combination with the VPC. So I hope you guys are good and you guys are ready. So let me just fire up my notes. And you'll discover that I'll be using my supplementary notes. I'll not be using the class notes. The class notes are yours to read. Should you want to go deeper, you can read that, but I'll be using my supplementary notes. I have supplementary notes that I created. And just a second. For those who have been asking for recordings, I hope you guys have access to this Excel sheet. This Excel sheet. Let me show you something here real quick. So on this Excel sheet, we have all the recordings per topic. You can see them here. All of them are here. So for the afternoon and the afternoon, for the morning and the afternoon session, for your morning session, we already have IP subnetting. The class that Joy taught, it's already in that form. So you just click and it will take you there and you'll be able to watch and even download. And then for any supplementary notes that we have that you want to share with you, we'll be sharing them here under files. So I'll add my supplementary notes for the networking, for the additional network protocol. I'll add it here. So you can click that and it will open a PDF for you, which you can read. Yeah, which you can read. I consider that those notes to be simplified because again, Staki Mlale class, it's this afternoon. I don't want you guys to doze. Yeah. You see how we care about you people. We don't want you to doze and then you chill blackout, if that is English, I think. So, now this aside, goes like that. So we are going to talk about additional networking protocol. And under additional networking protocol, what are the objectives of this lesson? What are the objectives of this lesson? Can someone read this for us? Somebody read these objectives for us.
Can you hear me?
Yes, I can.
Done.
Anthony?
So at the core of this lesson, we will learn how to identify other types of communication protocols, describe common transport application and network management protocols, and we will use tools to discover information about network communications.
Awesome. That is good. That is very good. So those are the three objectives that we seek to meet by the end of this short topic. So we are going to look at other different types of communication protocols that maybe we might not have covered, but you'll also meet those ones that we've covered. We'll describe the common transport application and network management protocols, and then we'll use some tools to discover information about network communication. So that is very, very important. That's very important. So let me drag my notes. Okay, yeah, good. So I have them side by side. That is awesome. What has happened? Sorry. Something weird happened. Are you able to see my screen?
Yes.
Awesome. Sorry. Okay. So I was defining what communication protocols are, and I was saying that protocols, simply put, protocols are just rules that define how data is transmitted between devices. And by devices, we mean, again, coming back to the on-prem environment, you might have, say, your computer connected to your printer, connected through a router, and then there are also switches in that topology. So when you look at it, the way in which data can move, say, from your computer to your printer, or from your printer to another printer, or from the router to your computer, that is defined by what we call a protocol. Now, there are different types of communication protocols that will come across, but these different types of communication protocols are divided into four main ones, into four main protocols. So the first protocol is what we call the transport protocol. The second protocol is called the application protocol. And the third protocol is called management protocol. In this slide, management and support have been grouped together, but let me get this one out of the way. But in essence, management and support protocol are two different protocols. There are two different protocols, but we are saying that we have transport, we have application, we have management, and then we have support protocol. So when you are thinking about protocols, maybe you can think of protocols as the languages people agree to use to understand each other. The language that people agree to use to understand each other. For instance, say in this course, at the moment we have one non-Swahili speaker. So we have decided and said that one of the languages, the primary language we'll use to deliver this course is English, just to accommodate our friend from Ghana. You see, similarly, as the program continues to grow, and maybe in the process of time we decide and say that we are going to be offering this program, maybe even to guys that are in other parts of Africa, or guys that are even outside of Africa. Now we want to offer this program to them. Then we will need to come up with a language that is understandable to all the participants. You see, so when you come back to what we're talking about in terms of communication protocol, by the way, if I ask you to define what communication is, how would you define it? Someone write it for us hapo kwa chat. Someone write it for us on the chat. How do you define communication? What is communication? What is communication? I'm already seeing some engagement. So I'm seeing someone talking about sender and receiver. Communication is a two-way traffic. transfer of encoding communication from the sender to receiver and feedback after. I like that, Musembi. So taken together, and ladies, please let us engage. So let us not move until a lady says something on the chat. We are waiting on you. This is a mixed class. This is not a male-only class. So I'm waiting to see you tell us something. You know, because you're actually the biggest when it comes to communication. I'm still waiting. Good reach for communication take place. There has to be a mode of communication and the channel, and of course the sender and receiver. Leonard is saying transmission of info in a way both sides understand. I like that. Ladies, who will save our ladies? One lady to represent, just one, and then we can move on. Very good. So I've seen Kayla said something, sending and receiving info in an understandable way. Prudence has also chimed in and said that it's the process of exchanging information or ideas. That's awesome. Thank you, Prudence. Thank you, Gail. Thank you, Rich. Thank you, everybody else that has engaged me. Now, the way I define communication, I like this definition that was shared to us when I was doing communication. What was the back in the day when I was in college? There is a unit that we did as freshers called Communication 101, Comms 101. So this lecturer defined communication this way. He said communication is a process in which one person, okay, he was using an example of people, one person called the sender communicates to another person called the receiver, and then this communication needs to be understood. Whatever the sender sends to the receiver needs to be understood so that the receiver acts according to or responds appropriately. You know, so it's not just a matter of just sending a communication, umesema tu, like the same way we do it in class here. When I teach something, or even going back to the example that we had with Clinton, when I say that there is this form that needs to be filled, that was me communicating. The receiver, I was the sender of that information. The receiver was Clinton and others. So unless the receiver acts accordingly, then that communication is not complete. The receiver has to act accordingly or appropriately as expected. So what does that tell you? It tells you even the communicator, the person that is sending the information, must send the communication in the right form, with the right information, with as much detail as possible, so that, okay, to increase the chances of the receiver understanding. I hope that one makes sense. And sometimes the receiver also stands an opportunity of asking follow-up questions so that they can understand the information better. You know, now back to our example, when we are talking about protocols being just like languages, we mean that when you use these protocols, then the medium through which you are communicating, or rather the device, if let's say there are two devices that are communicating, these devices are able to understand the data that flows from receiver to from sender to receiver, because it is using the appropriate protocol or the appropriate language. So we had talked about the different levels of the OSI model, and we talked about the form in which data is when it is in different layers of this model. Now, we are looking at some of these layers, and two of the most important ones that you will keep seeing recurring even when you come to the cloud are the transport and the application layer. So at the transport layer, the protocol that is most used at the transport layer, two protocols that are most used are the transmission control protocol, TCP, and the user datagram protocol, UDP, which we already talked about. And if you remember, please chat with, write it on chat. If you remember the key difference between TCP and UDP, please write it on chat. If you remember the key difference between TCP and UDP. Please write it on chat. I want to see those who are in class and those who remember. I am waiting. It will be nice to see the first answer coming from a lady, but oh, the rate has already beaten you to that. Yes, TCP is connection oriented. Thank you, Angela. That is good. TCP connection oriented, UDP connectionless. Wonderful. One is connectionless. The other one is a session must be created. Now, which one? When you tell me one, which one, Salem? UDP is connectionless. Awesome. At least you remember that. And that's a very important distinction. Always remember that. So TCP, we say it is connection based and UDP is connectionless. That is awesome. Thank you so much for that. Then another category is what we call the application protocol. And now under application protocol, you will see the like of HTTP and HTTPS. Yeah, so HTTP and HTTPS, and then you will also see the likes of FTP and SMTP and DNS. So FTP is file transfer protocol. FTP is file transfer protocol. FTP is file transfer protocol. Just a sec. No, let us not talk about FTP here. Let us drop FTP. We'll talk about FTP in the support and management category. But firstly, when you look at application, you have HTTP, HTTPS, you know those ones, and you use them. And then we also have secure sockets layer, that is SSL. SSL is secure sockets layer. And then we have TLS, which is transport layer security. And then under application, when we now talk about mails. So under mail protocol, we have SMTP, simple mail transfer protocol. And then you have post office protocol, POP. I know if you have looked at those things, you must have seen POP somewhere. You must have seen POP somewhere. I like that meme. Kube, you remember Musembi. And then there is internet message access protocol. Internet message access protocol, that is IMAP. So those three specifically, that is SMTP, post office protocol, POP, and IMAP. All of those fall under application protocol, but under another subcategory within it called mail protocols. Next, we are seeing there is a remote desktop protocol. And of course, for remote desktop protocol, these ones you have at least used them. So for guys on Windows, there is actually a way that you can use remote desktop protocol, RDP, to connect to your instance, your Windows instance. So when you're connected to your Windows instance remotely, you use remote desktop protocol. Those who have had an opportunity to use VPSs, virtual private servers, then you must have gotten a way around using a remote desktop protocol. And then of course there is Secure Shell, which we have been using since we started Lab 1. So those are application protocols. Now let us combine management and support protocol, and we say examples here include the domain main system. We defined this and we said what it does. We have file transfer protocol for file transfers. We have dynamic host configuration protocol, which assigns IPs. Then we have Internet Control Message Protocol, ICMP, Internet Control Message Protocol. So those ones are management and support protocols. I hope that one makes sense. So these notes are just what we have been spending talking about: connectionless and connection-based. All that is there. Now, the OSI model, I'll not repeat this because we spent a long time doing this. The recordings are available for you. You remember what we said: data enters from 7 to 1, data flows from source from 7 to 1, and then it goes to target from 1 to 7. You remember we talked about that? So the same thing has been explained here. Everything that you're talking about has been explained here. Has been explained here. So this is just a replica of the same slide that we talked about when you were looking at the OSI model. And I invite you guys to go back to that recording and just engage yourself just to understand. TCP. remember what we talked about TCP. We say that transmission control protocol is a connection-oriented type of protocol, and here handshake is required. Handshake in this sense, the sender sends what we call a sync, and then the receiver sends back what we call a sync acknowledgement, and then the client sends what we call an acknowledgement, and then that connection is done. So it is a three-way handshake. So in case in any of your future interviews, you are asked to explain how a three handshake protocol or process works, you will say it starts with the client sending sending a sync to the receiver for the purposes of starting a connection. And then the receiver, which can be a server, sends back a sync to acknowledge the request from the client. And then the client sends what we call an acknowledgement to confirm the connection. You see, so you start the connection, acknowledge the request, and then confirm the connection. You know, and then if you want to do graceful close, we talked about graceful closing of this entire thingy when you're using TCP. When you're using TCP, we say that for graceful close, then a fin will be sent, and then a fin acknowledgement, and then acknowledgement. You see, fin is that I am finished doing what I was doing. Then actually client sends finish, asking the server, have you finished? Then the server sends finish acknowledgement to say, yes, I have finished. And then the client says, I have acknowledged that I've received your communication, that indeed you have finished what was doing. And then that connection now terminates. You know, that is how TCP looks like. And you have everything here just to bring you to that understanding. Next, closely related to TCP, or rather something that can be compared or contrasted with TCP, is the UDP. And we say that UDP uses a simple connectionless communication model to deliver data over an IP network. So when you compare it to TCP, UDP provides only a minimum set of functions. It is considered to be unreliable because it does not guarantee the delivery or ordering of data. As you can see, let me give the right credit. Let me see who did that. Naboth, yes. So Naboth has shared one of the memes that we had during that class, where you can see what TCP does. We have a mother laying a baby to sleep, and the cot is right there. So the baby will have what we call soft landing. So from the mother's hand straight to, maybe let's say the straight to the cot. But the other one, that UDP, the UDP mama, see how she has thrown that baby. You might think that she's throwing the baby to a basketball court, basketball, whatever. How do you call that thing? How do you call that? Okay, the basket that receives the basketball. So the way she has thrown that baby, well, please don't try that at home. Future parents, don't try that at home. This is racist. Why? It is racist. You say it's racist because they have used a white woman laying the baby to sleep, and then I did not see that. But take it easy. It's just but a meme. All right. So that is how a connectionless and connection-oriented type of protocols work. So we say that connectionless has no handshake. It is fast but unreliable. Some common use cases that we talked about during that time again is things to do with video calls, and gaming. Remember? And then, of course, when you now come to compare the two of them, you will now understand what they are, how they are used. So examples of TCP, or rather, an example of let me go back to this slide and check something first. Yes, so examples of TCP, or example of connection-based protocol. We have two examples, and you've seen them, and you will continue to see them. We have the likes of HTTP and SSH. HTTP and SSH, both of them are actually considered to fall under TCP. And you will see it when we start working on our labs, and when we go into the console, you'll see us define these kind of things in the, when we are under networking, you'll see us define that under networking. Then examples of UDP, we have the likes of DNS and streaming. And streaming, we've talked much more about streaming. And so that was very important. Very important. So again, when you get to this slide, it is repeating the same things. That's why I'm just brushing through them. It's repeating the same things where we are talking about connection-oriented protocol, you know, which is similar to a phone call between like, let me see, someone is telling me what. Okay, which is similar to a phone call between two people, you know, a phone call between two people. And then we also have connectionless protocol, which is like sending a letter from one mailbox to the other. And we talked about that, remember? So those differences are for you to talk about. The handshake is explained here even more better. Now, the same thing that I've described is what you see here. Sync, acknowledge, and then done. Then maybe fin acknowledge, then acknowledge, stuff like that. So these things, if you've gone through your previous notes, the ones that we were doing when we were talking about TCP and UDP, you'll discover that it is the same word for word, even for graceful finish, where we talked about fin acknowledge and stuff like that. Then next, we move on to application protocols. So under application protocols, we had already talked about this in passing, and we say that we have a number of examples. So one of the examples is HTTP. So HTTP is the protocol that is used to reach web pages. A full HTTP address is expressed in a uniform resource locator. Are you seeing now why these things build on each other? When we're talking about networking concepts, we talked about URL. I told you what URL does. Now it has been re-mentioned here. So we have that, and then we have secure hypertext transfer protocol. So secure is the S that you see in HTTPS. You get? It's a combination of HTTP with SLS or TLS protocol. When you combine those two protocols is when you now end up with what? With HTTPS. So for HTTP, basically its use case is for web browsing, and it has a specific port. So all of these protocols that we're talking about, they have their own ports, the ports that they use. But even before we get to that, let us look at the anatomy of an HTTP, or anatomy of a URL. And here we're using HTTPS, a combination of HTTP and SLS/TLS. So here you'll see the protocol has been defined at the very beginning, and at the very beginning of the URL, and it is HTTPS. Then we have a colon, double forward slashes, and then we have www.amazon.com as our domain. You understand? That's our domain. And then the path within that domain is prime-video, then /b?node. The whole of that is the path, you know. And then now another bit that is also considered to be a domain is movie.html. So that is what you see as your URL. Just take it as is. And we've already talked about what HTTP and that one does. And then, because we've said that HTTPS is a combination of SLS and TLS, let us look briefly at what these ones are. So when we are looking at SSL, we say SSL is a standard for securing and safeguarding communication between two systems by using encryption. So we had mentioned about encryption in passing and promised that you guys are going to learn more about encryption when we get to security, maybe in the course of this week. So just remember that this is just a way of making sure that you secure and safeguard your communication by using encryption. So that's what we call SSL, okay? That's what we call SSL. Then for TLS, TLS is an updated version of SSL that is more secure. It's more secure than SSL, and many security and standards organizations, such as Payment Card Industry Security Standards Council, that is PCI SSC, require organizations to use TLS version 1.2 to retain certification. You know, so payment processors or payment card processors are required to use TLS 1.2 to retain certification. And maybe by this time, it might have gone a bit higher in terms of the version that they're supposed to use, because there is always an improvement with other versions coming out. And then we have what we call a TLS handshake. So this is the process that initiates a communication session that uses TLS encryption. You remember we talked about the TCP, the TCP handshake. Now we have a TLS handshake, which is a process that initiates communication session that uses TLS encryption. So during a TLS handshake, the two communicating sides exchange messages to acknowledge each other. You know, they acknowledge each other, like sender acknowledges receiver, receiver acknowledges sender, and they also verify each other. You know, they establish the encryption algorithm that they will use and agree on session keys. You see, it's like two people, you have to agree that this is the encryption algorithm that we will use, and this is the session keys that we'll use. So TLS handshake are foundational part of how HTTPS works. It's foundational part of how HTTPS works. And you will see that there's actually some explanation here, and I'll skip right to the tail end because everything else I've explained. I marked this as important to note that to provision, manage, and deploy public and private SSL or TLS certificates for use with AWS services and internal connected resources, you will need to use what we call the AWS Certificate Manager. So AWS Certificate Manager is a service within AWS that enables you. It enables you to to provision, manage, and deploy both private and public SSL or TLS certificates, which will then be used by what? By AWS services. Hope that one makes sense. Hope that one makes sense. And then just going through, should I leave that one first? Let me see. Okay, just going through this. You remember we talked about the different mail protocols in our example where we said that we have SMTP, we have POP, and we have IMAP. So you are being shown here an example of how things flow. So let me start explaining from here. We have a mail client, we have another mail client, another mail client. So you see, so information flows directionally. So we go through a mail server from a mail client to a mail server. This is the protocol being used here. So initially here, from this to this, we are using POP, you know, then from this to this, we are using IMAP. The difference is almost the same. Thing is, it depends with the kind of message that you're trying to pass. But now see, we come to the mail server, then we start using SMTP to the internet, then SMTP to and from the internet, the same. And now what you see here is what has been replicated on this other side. It's nothing different. It's what has been replicated on this other side. So information coming from this mail client can go through POP and actually go to the other mail client without going through the mail server. And mostly this is normally used, especially if you're trying to send an internal mails. Internal mails does not go outside your corporate network. It will just go straight to the recipient that's supposed to receive if they are within the organization. But now if it is going out, it will go through a mail server to the internet and then find its way to another mail server, which will now serve it to the final recipient. I hope that one makes sense. Then we talked about RDP and SSH. I told you that when you want to connect to your Windows instances in the cloud, the easiest way to do it is by using Remote Desktop Protocol, RDP, and it's possible to do it. The process is the same as the one that we've been using for SSH. Only the difference is that instead of provisioning an Amazon Linux server, you will provision a Windows server. You understand? You'll provision a Windows server. Then once you have your Windows server, you'll now be able to use RDP. How do you call it? Most Windows machines comes with the RDP. Let me see if I can get mine. Here it is. And if you can see here, are you seeing these instances? This is an instance, this is an instance. All these instances are instances that I connected to using my RDP client. So let me just open this. You see how it looks like. So it normally looks like this. You'll enter your computer name. Let me try. Will it really go? Let me try and say test. I just want to see if it will. It will not. No, it will not. 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 I must have my computer. But this one's. So there is a link that you'll be given. There's a link to your instance that you'll be given. Okay. There's a link to your instance that you will get. Then that is the link that I doubt if this is still running. It's kitambo since I used it. If it's running, I'll need to go and shut it down very fast because it might be incurring spend. You see, this is not failing as fast as the other one because the other one already had a name that does not exist. So this is an instance that I had created, but that instance, I terminated it. It's actually best practice, especially if you're doing your own projects. Always terminate what you're not using so that you don't incur spend. So Salim is saying creating a Windows EC2 instance requires one to access the instance using RDP. Yes, you can only access a Windows instance remotely using RDP. I hope that one makes sense. So there is this small client for guys using Windows called the Remote Desktop Connection. It is native to Windows and it actually comes with your machine. So you don't need to install anything. You just do that and you'll be able to get to your instance. So they are both essential. So we are saying that both SSH and RDP are essential for securely accessing cloud-based servers, and they also help in remote. They also aid remote employees using infrastructure on-prem. So you might want to use infrastructure that is on-prem, but you are maybe in a far-flung area. So it is very possible for you to connect via RDP. You get access to that server that has been designated for your team, and then you'll be able to access anything that is within that server. You know, it gives you access to that. You understand? So that's very important. And you can read that too to help you get a better understanding. So application protocols, let me see if I missed something. So for application protocols, the table that has been presented for us here shows the network protocol and port numbers that common application protocols use. So if you're planning to become a very good cloud engineer or even DevOps engineer in the future, one of the things that you really have to be very, very familiar with as early as now are the port numbers. Understand? The port numbers, because different protocols use different port numbers. Think of port numbers as like doors that gives you access into a house. Think of them that way. So you are told that different protocols access servers or access your workloads in the cloud via different port numbers. It's just the same as, say, you've gone to a place like where? Let's use an example of Nyayo Stadium. Sorry, Frank. I'm just using something that's a bit familiar. It's just a stadium, and I believe maybe you can type for me there on the screen the name of a famous football stadium in your country. So we are using an example in our country where we have like Nyayo Stadium, and then you have this event that brings together different. Maybe there's this big soccer event that is happening, and then we have different people that are coming in. And for stadia such as big as this, it is very, very possible for us to have different entries and different exits. And you get that some of these entrances are actually reserved for specific persons and personalities. Like maybe we have one general entrance for everybody, then we have another entrance for VIP, and then we have another entrance for VVIP. You see, so think of it that way. So when traffic is coming, let's say maybe normal entrance is HTTP. Anybody, HTTP, you enter through this port. That is port 80. Then HTTPS is for VIP. So HTTPS goes through port 443. And then the likes of FTP, SSH, and DNS, they are both VVIP. So they go through a different port. But here you can see their numbers are different. So you need to get these numbers stuck as early as now. And remember what I told you, when you mention something that is important for you, not just for exams, even for your own practice, make a habit of creating screenshots, and you can actually have this as what? Sticky notes or something, because even when you go to interviews, you might be asked a simple question. HTTP communicates through which port? And then you start chewing. You know, just know 80, 443 HTTPS, 21 for FTP, and SSH goes through 22, while DNS does what? DNS connects via 53. You know, and for DNS, it's so interesting. There's a day I asked somebody, why is DNS using port 53? And then AWS also has decided that their DNS service their DNS service is actually called Route 53. You see, so Route 53 and port 53. Are you seeing that a kind of similarity? So that one helps even to remember better, to memorize these things better. So unused port numbers are usually closed for security reasons, serving as gateways between installed software on the client computer and the server. Ports can also serve as pathways for malicious attacks. I want you to really allow that to sink in. Ports can also be used as pathways for attack by malicious actors. So it's very important that when you are defining maybe your security groups, you are supposed to say, I want it to allow traffic through here and disallow any traffic through here, or traffic from this other place, I want it to come in through these different places. I hope that one makes sense. Then, again, back to my supplementary notes. When we look at, you'll get to read that. When you look at this support, management and support protocols, we have like 4 of them, 4 very important ones. The first one is called DNS. The second one is THCP. The third one is ICMP, which I already talked about in the beginning, and FTP. So for DNS, it translates names. You know, it translates names, the domain names that you give, into IPs. Remember what an IP is. We say that an IP is a unique address where different pages or different systems are found in the cloud or on the internet. You know, then we say we also have something that we call DHCP. So the work of DHCP is to automatically assign IPs. We'll not belabor that because you already described it and discussed it. Then we have ICMP, which sends network error messages, and it is normally used in ping. There's a tool or a utility called ping that you can use to ping different websites. I believe during the morning session, Joy told us something about ping. And then there is also something that we call FTP, or file transfers. So you can put is actually to send a file. So you can put a file, say you want to put a file to S3. So you can put a file that is sending a file into S3, or you can get a file or retrieve a file from S3 or any other storage service, getting a file. So we have put and get, which are done using FTP. And we had said the port that FTP uses, if I may confirm, FTP uses port number 21. So looking at the DNS, DNS is simply what we talked about the other time, and we say that the DNS, the work for DNS is actually to translate names into IPs, and think of DNS as the phone book of the internet. You know, it finds the IP behind a name. Maybe here you are typing www.landlyafrica.com. Now, when it goes to the internet, the DNS, it's the work of the internet, of the DNS, to look within its phone book and search and check which IP matches www.landly.com. That's the work of DNS. Don't confuse DNS and DHCP. We say DHCP, its work is to automatically assign IPs. Okay, good, awesome, that's awesome. So, So what I've just told you is all of this. So I'm not going to belabor this ICMP, DHCP, FTP. All of these are just repetitions of what I've talked about. So you guys will be able to brush through those notes and you'll be good. You'll be very, very good. Now, I want us to look at some troubleshooting tools, some network troubleshooting tools that have been available to us that we can use to check the state of our network. And one such tool is called ping. Ping is the most common tool used to test connectivity. This tool tests whether the remote device or server or desktop is on the network. You know, it tests to see if it is on the network. If you ping something, it's supposed to check if it is on the network. The reason why you are able to, for example, ping google.com and get a response is because google.com is on the network. The reason why you are able to ping, let's say, amazon.com and get a response is because amazon.com is in a network. And which network are we talking about? It is on the internet. We say that internet is the biggest network available. It's the biggest network that we know. So you can ping any site. Let me see if I can bring up my CMD. I'm going to use my command prompt. Let's try and ping google.com. You see? So for you to know that it is working, let me make this one bigger. Okay. So I can make this one bigger here. Good. The box. Good. So you see, when you ping, like we've just pinged google.com, the first thing it tells us of the IP. Then after the IP, it now checks. You know, it now gives you back the response. By pinging, we are sending a request. We are asking, it's like you're asking google.com, are you online? You know, the same way I will take my phone and maybe call Frank and ask Frank, hi, are you online? You know, then Frank will give me a response. Now, when Frank gives me a response, is what you see Google doing here. You see, it's replying and telling you that, yes, I am online. This is me. It has taken me this time to answer. It has taken me this time to answer. Kiprona, I can see you. It has taken me this time to answer. You see. Then let us try. Let us try and see. And you see, this is outside the content of this course, but you can see it tells you how many packets have been sent by the sender, how many packets have been received, and how many packets have been lost. So there's a possibility of packets being lost in the course of transmitting data from the sender to the receiver. But in this case, you can see that it has not been lost. See that? You see that has not been lost. So let us try and ping one more. Let's try and ping Landly. Just a second. Let me make sure I get the right domain. Oh, I know the problem. Yeah, so I get it. So let's try and ping this. Oh, I type Landly Africa.com. So I had not checked this. Let us just check it together. You see, the website is on. So one of the use cases that you can use this one for example, let's say you are assistant administrator and you're trying to check. Maybe someone is telling you that that our website is offline. No, the website is offline. So you can try and ping and see if it is available. Let me ping a website that I know very well is offsite, unless they brought it back. For Sky, this is a community that I'm part of. So let us try and ping this. Our website is supposed to be offline. You see, ping request could not find host this. Please check name and try again. Could not find that host because the host is actually offline. The host is offline. Very, very finally, let us try to ping. What can we ping? Let us ping x.com. I hope this is the name for X. Yeah, so you see, it's giving us results. You see? So that's possible. And Joy said this in passing. She said it very lightly, but it is true. Ping is one of those tools that is normally used by hackers. I'll not classify them. There is black, there is gray, there is white. Here nowadays there are also blue hackers. Black hat, blue hat. So ping is normally used as a tool for reconnaissance. You know, reconnaissance is like pre-visit. You first of all want to make sure that the site that you want to do proper work on, whether you are doing it as a security analyst or otherwise, you first of all want to make sure that that site is online, so you can use ping. So ping is one such thing that we use. Let us try, I don't know if this will work, but we're just trying. Let us try NSLOOKUP. So our next CLS, good. NSLOOKUP for google.com. See, it's telling you the server is unknown. Of course, it's unknown because they have to mask it. They won't just tell you everything. And then you have that as the address. And then it tells you the name is google.com. That's what we are looking for. And then every other thing that maybe you can use if that is what you are looking for. You know? So you are asking what is 8.8.8? Who knows what is 8.8.8? I think that's Naboth asking, eh? What is 8.8.8?
Google.
Yeah, that is their public DNS. That is the public DNS for Google. You know, that's the public DNS. It's the public DNS. But remember, we are not looking at the DNS. We are looking at, we are asking for its IP. DNS and IP are two different animals. So NSLOOKUP, let us look for, let us try NSLOOKUP for, let's try that. You see, so Landy, you're also getting results. You know, we're also getting results. So it is showing us where we are coming from. So I believe from these results, since these and these are constant, this is actually my current IP. From where I am asking, I am the sender. I'm the one who is sending NSLOOKUP. NSLOOKUP is a request. You know, this is a request that I'm sending out. And then I'm getting a reply. Now okay. They're telling me that the answer that we are getting is, yeah, the name is landlyafrica.com. The address is 185.that. You know, and then we also have these others. So that is good. That is good. Then another thing that we can look at is, apart from NSLOOKUP, let me clear this for CLS for Windows. Okay, good. So apart from that, this one I ran it the other time. Which one? One of these two will refuse. But let us try. Has my notes gone? One sec. One of them will refuse. Let me get my supplementary notes and see if I got a workaround. It's one that is supposed to refuse. Not supposed to, but it will. This one. Okay, not that one. Just a sec. Yeah, I believe this is it. Okay, so let us try do the trace route. But now for Windows, for guys on Windows, you will not use trace you will not use trace route. Trace route is used by guys on Linux and Mac. But for Windows, you use what we call TraceSat. TraceSat, and then you include the name, the name of the website, Amazon.com, for example. Let's try that. It's not recognized. And the simplest reason why it's not recognized, this is a Windows issue. It's not that the command is not working. It's just a Windows issue. So I have not done the proper configuration, you know, environmental paths and environmental variables and stuff like that, not set at the moment. And I'm not going to set it right now. because that will take me some time. Let me try Telnet and see if Telnet will work. I suspect this one might also refuse. Amazon.com, looking at port 80. Oh. Oh. So it connects. Okay. But there's really nothing that I want to send there. So that looks good. That looks good. Telnet connected finally, but it had refused initially when I was trying it out. So these are just some of the tools and utilities that you can use. And we are told that for ping, we used to test connectivity, just the way I had explained. This tool tests whether the remote device or server or desktop is on the network. Then NSLOOKUP queries the DNS and its servers. It shows the IP address that are associated with a given domain name. Like you saw for Lanly, Lanly is actually associated with 3 IP addresses. And then you see we also have traceroute. Traceroute permits users to see the networking path that is used. It's helpful for troubleshooting connectivity problems. So there's a possibility that yes, everything is working, or there is some slowness in your network, and you want to try to understand what is happening. How is data moving from one part to another? And then you'll be able to look at the number of hops that it takes to move maybe from the server to the recipient and stuff like that. Then very, very finally, we talk about Telnet. Telnet is used for service response. This tool tests whether the service that runs on the remote device is responding to requests. As you can see very well, Amazon.com responded, meaning that it is up and running. You know, it means that it is up and running. So all of these are just what we have tried to run ourselves. You know, we've tried to run ourselves. I have not yet configured an instance. We would have run this to see, but that one requires you also to have a server running. So traceroute and stuff like that. So all of these notes, remember these things when you are reading, by the way, point to note, anything that we are doing today and tomorrow morning, those ones are just additional to fill any blanks that were left when you were starting. But they are not two things. One, they'll not come in your exam. That's number one. And then number two, they are not meant for you to master them now. I've told you that there is a specialty level for networking. You know? No, so I don't want you guys to scratch your heads seeing these black screens. You know. So all that, I know it's important. It's important. So we've talked about all this stuff, and now you'll be able to run them. I'm avoiding to run hping because hping, if I run hping on a site that I would want to access later, it might flag me because hping is normally used to continuously ping. It's like you are pinging on repeat. So I don't want to do that right now. I don't do that. It is something that people do when they want to. Okay, it's an improvised version of hping people use to launch things like DDoS attack, denial of service attack. You know, so remember, we are teaching you these things, not that you go and use them to do bad things. We are teaching you this. With the knowledge comes responsibility. Please do the right thing, because these organizations have employed people who are better at defense than we are at attacking, so they can easily locate you where you are and even launch an attack against you, and you won't like it. You know, you won't like it. So let us just tread on the safe side. Then there's an activity here, enter ping. We did that. Enter NSLOOKUP. We also did that. So everything I was doing is just part of this course. I don't have access to Linux at the moment, but those guys that are on Linux, or once you provision an instance, you can try this out. It's normally good for you to see it work on your side. It's actually very good for you to see it work on your side. Now, checkpoint question 1 of 4. Okay, let me read this first one and listen carefully. A developer tries to initiate a connection to a company's local file transfer protocol, FTP server, by using its IP address. However, the connection fails. As a result of the connection failure, the system administrator decides to troubleshoot this issue for the developers. Which procedure can the administrator follow to troubleshoot the developer's connection? Anyone with an idea before we read the answers? Anyone with an idea? Mhm. You guys, you should not be afraid to try. These things is just a matter of trying, because these are some of the questions that you are likely to meet when you are doing your interviews, or even when you get into the job. So assuming that this is you, and a developer reports to you and tells you that I'm trying to connect to the FTP, but it's not connecting. What are you going to do? What are some of the steps that you will follow? Tony says you need to include the port number for FTP. Yes, but which tool are you going to use to check for that connectivity? Which tool are you going to use? Which tool? We already talked about it. Yes, it's ping. You will ping that to see what's happening. So so you will first of all test for server connectivity with the ping command, and then you will also check the firewall rules to verify that port 21 is open. Remember, when we were talking about those ports were not just for decoration. You remember I told you that different doors allow different kind of traffic. So port 21, if port 21 is not opened, it does not allow for traffic. Let's say, for example, this file server is in the cloud and you've not allowed traffic from on-prem to the cloud via port 21. You've not opened port 21, then of course when you try to access a door and it is closed, so of course you won't get in. So that's also something important for you to check. Very, very important. Question number 2, which protocol automatically assigns an IP address and other IP parameters to each device on a network so that these devices can communicate with other IP networks? Which protocol? Which protocol? DHCP. Yes, DHCP. That is Dynamic Host Configuration Protocol, and we talked about that one. So next question, which command can test whether a port on a remote computer is opened? Which command can test whether a port on a remote computer is opened? So the answer given is SAMP, and then of course you have greater than sign telnet. So telnet is important, and we ran telnet, and you saw telnet to Amazon.com. It connected because it shows that is open. But now, which protocol is used by applications that prioritizes speed over guaranteed data delivery, such as video streaming services? This one we talked about it. Ladies, where are you at? Which protocol? Yes. Thank you, Abby. Thank you, Gideon. Thank you, Salem. Guys, please participate. Participate. It's UDP. And then, what is the role of domain name system, DNS server? What is the role of DNS? Don't worry, Mark. Don't worry, Mark. We will avail the recording for you and you'll be able to catch up. Don't worry. Sorry for that. Sorry for the network issues. So we're asking, what is the role of DNS? So again, we said there that the work is to convert human-readable domain names such as Amazon.com or example.com into IP addresses. And then which protocol can send mail from the client to a server or transfer email between email servers? We saw that also as simple mail transfer protocol, SMTP. Next, which protocol defines how to establish and maintain network communication and also ensures that data packets are well received? Which protocol is that? Gail, TCP, very nice. Then, which protocol network device which protocol network devices diagnose network communication issues and generates responses to errors in IP network? Someone answer that. Which protocol? Device, network device? Traceroute. It is ICMP. It's ICMP, Internet Control Message Protocol. Remember, I told you that when it comes to these things, always look at the keywords. But that was a good attempt, Salem. Now, someone unmute and read these key takeaways for us, please. Then we go straight into the lab. Someone?
Hi, Patrick.
Hi.
I'll read.
Okay.
TCP and UDP are transport protocols. TCP is connection-oriented and UDP is connectionless. Common application protocols that are used on the internet include HTTP, TLS/SSL, SMTP, and FTP. Common network management and support protocols include DNS, DHCP, and ICMP. Common utilities that are used to discover and troubleshoot network communication include ping, NSLOOKUP, and traceroute.
Thank you, Gail. That was awesome. So, Sharon, UDP or TCP for delivery. So, remember what we said about UDP. We said that UDP is connectionless and TCP is connection-based. So, both of them are used for delivery, but one of them does not care if the recipient is in a position to receive what is being sent, and that is UDP. And then Salem asked something about, says something about traceroute. It's true. Traceroute is not a protocol. Traceroute is a network utility. I normally call them network utilities. They are tools that we use to check different aspects of the network. I hope that one makes sense. ICMP is used with ping command for troubleshooting. Good. Awesome. So that is all about the additional networking protocols. And I'm going just to shift gears immediately and go into the labs, because my plan was to release you guys a bit early so that you can go and do your group work. But you're lucky because we are going to do that lab here together, so that when you go there, it will be very easy for you guys to do the lab. So I guess you guys will be able to do the lab. So that is lab 267. That's the lab that you're going to be discussing. So let me just start it. Sorry, the notes took longer than I had anticipated. I thought that I'll be done faster, but we are still good. And I want you guys to pay absolute attention to this lab. Absolute attention. Let us just start the lab. So guys who have not done even a single lab, this is something that you should be paying attention to. So the first step you do is you click on Start Lab. I hope that people that I'm not going to mention their names because of a very simple issue. They are new. And so they are not to blame. They just came in and found us going. But we'll help them catch up as long as they are willing to put in the extra work. There's someone I'm not seeing in class. Is she around? Is Mary around? Mary. Mary. Mary is
I
not
think
around.
she's not around. I checked her in the morning. She wasn't around.
Though she had stepped in the morning because I marked her present. I saw her in the morning, but she came in a bit late. Esther, we'll need to talk about her after this.
Yeah.
We'll
Sure.
need to talk about her after this. Okay, cool. So my lab is ready. I hope for those ones who want to follow, your labs are also ready. So we are told that this will take 45 minutes, but we'll finish faster than that. So don't worry about it. After completing this lab, you should be able to create a VPC, create subnets, configure security group, launch an EC2 instance into a VPC. This lab takes approximately 45 minutes, and then this is the scenario. In this lab, you use VPC to create your own VPC and add additional components to produce a customized network for a Fortune 100 customer. You also create security groups for your EC2 instance. You then configure and customize an EC2 instance to run a web server and launch it into the VPC that looks like the following customer diagram. So I had mentioned and I had talked about this kind of diagram. This is what we call an architecture diagram. It's similar to building a house. You don't just wake up and start laying bricks. You have to have a diagram that shows I'll have this many rooms, windows will be in this corners, pillars will be in this corners. I'll need a veranda here and there, stuff like that. That is very, very possible. Understand? That is very, very possible. So, so that is possible. So we'll be looking at this, and you guys are fortunate because you're being introduced to architecture diagram at CCP, and you will also be able to, you'll also be able to draw these diagrams yourselves, especially say you leave CCP and then you go to an Amazon partner network that takes people at CCP level without solutions architect, because most of them actually require you to have a solutions architect associate certification. But if you go there at this level, this is one of the things that you learn on the job. You learn how to draw this, and you'll be drawing even complex ones. You know, I remember I was in this internship some years back where we were shown the architecture diagram for Barclays Bank. I think nowadays it's called ABSA, something. ABSA. For ABSA, we were being shown the architecture diagram for ABSA. And you see the various layers. And of course, for ABSA specifically, they do a combination of different clouds. So you can imagine how complex that diagram was, but it was really a beautiful sight to behold. Just looking at that architecture diagram and seeing how these different things do. And then again, if you are on LinkedIn, you might have come across other architecture diagrams, like let's say the architecture diagram for Netflix, to see how the different services are connected to each other, you know. And Salem is asking about tools that are used to draw these diagrams. I already told you guys in another class that one of the tools that you can use to do this is called Chora, Draw.io. Draw.io is one of them, and Lucid Charts. There are others, but those are the two most common ones used, and I've used those ones. So where is this? Let me write them here. Let me just write them here. Draw.io and Lucid Charts. Lucid Charts. And then you can also, if you want to draw wireframes, flow diagrams, and stuff like that, and sometimes, okay, mostly things that you can do, you can also look at an I think it's called, is it napkin.io? Just search. Okay, let me just search it, just that I give you the right thing. Control napkin.io. Is it IO? Build and deploy. Napkin. I want napkin for .io. Napkin for. I don't want the AI thingy. I'm seeing napkin.ai everywhere. Kwani it converted itself. Back then it was napkin. It was napkin. I don't remember. Oh, Musembi saying VCO is also good. I haven't used that. For napkin, just leave it fast. When I remember the right one, I'll tell you. So this is the diagram that we have. You can see that we have the AWS cloud on the outer. Inner, we have our region. We talked about the regions. Then inside each region, we have a VPC. Remember we said you can have a maximum of 5 VPCs, but you can ask for quarter increase. You see? And then now we have an internet gateway at the boundary of the VPC to give the VPC access to the internet. And then we have this public subnet. Inside it, we have a web server and a security group. Then inside this other public subnet, we also have what? We have a NAT gateway, and then we have a private subnet and another private subnet. You see, so this is a 2AZ kind of a setup where you have like two availability zone A and availability zone B. And then we have the route table, which defines and tells you the route that internet is going to flow to and from the internet gateway. And then we also have this public route table and a private route table. We also have another one that we call what? A private route table. Okay. All right. So this one comes from local to NAT gateway. Now it's NAT gateway that gives access to this. It gives this access to the internet, maybe to pull whatever it needs to pull, stuff like that. If we have a workload here, it will be able to pull updates and patches through the NAT gateway. So, of course, the restrictions are kama kawaida, are as usual. You will be restricted only to services that have been provisioned for you, services needed to run this lab. And then this is this one we have done. We have started our lab. Our lab is running. You saw that the lab is ready. Then we can click on AWS. Okay. I'm going to go into split screen so that we can do these things side by side. So let me do this. And then let me get okay. So let me get that and this. So this is what I need on this side. Okay, good. I hope you can see my screen. If you can see my screen, thumbs up, please. If you can see my screen, thumbs up, please. I am not seeing any thumbs up. Okay. Thank you, Prudence. Thank you, Purity. Thank you, Salem. Okay, thank you, guys. Awesome. So we are going to start on this lab. So we are told here that task 1 is to create a VPC. In this task, you use VPC Wizard to create a VPC, an internet gateway, and 2 subnets in a single availability zone. Remember, single availability zone. An internet gateway is a VPC component that allows communication between instances in your VPC and the internet. So after we create the VPC, you can add subnets. Each subnet resides entirely within one availability zone and cannot span zones. This is an examinable question. Each subnet resides entirely within one availability zone. So subnets are zone specific. They cannot span zones. If a subnet traffic is routed to an internet, gateway, the subnet is known as a public subnet. If a subnet does not have a route to the internet gateway, that subnet will be our private subnet. You understand? Then the wizard also creates what we call a NAT gateway, which is used to provide internet connectivity to EC2 instances in the private subnet. I mentioned that. At the upper right, choose AWS. We've already done that. Once you are in the AWS console, type and search for VPC. So we just follow that step by step. I have my shortcuts, but we are not going to go through my shortcut today. Today we'll just do what they are saying. So we do VPC. Okay. So we have VPC. We've searched for that. We are on point number 5. Select VPC. So we'll select that by clicking it. Okay. Then point number 6, you are now in the Amazon VPC dashboard, which is loading. You use the Amazon VPC cloud service to build your VPC. So that's what we'll use to build our VPC, right? Okay, all right. Point number 7, choose create VPC. You see, it's just step by step. Labs are just like a menu that you use to cook, yeah? As you used to cook, you follow step by step. Add this salt, add this water, add this Royco, add this here. Yeah. One day Frank should share with us a recipe for cooking. Is it jollof? Jollof rice, Ghana style. I hear that dish is the Nigerians are competing with Ghanaians in terms of the origin of that dish. So you will, Frank, prepare for us a good recipe. You must be having one. You must be having one. It's called intercultural exchange. Then we will give you a recipe for ugali. Yes, Musembi, you can prepare for us a recipe for ugali that we can share with our friend as he gives us his. I am torturing. Okay, all right. So let us create this VPC. So resources to create, we choose VPC and more. So in the morning, so we have this VPC first. So we'll create, we'll click on VPC. We were to click on create VPC. So we have clicked on that. Okay. Musembi wants to give us the recipe for Mudokoi. Okay, do that. We'll appreciate. So we are going to create our VPC. Now, there was VPC only and VPC and more. So we are going for VPC and more. You know, in the morning you did VPC only. So right now we'll do VPC and more. Click on that. Once you click on that, I want you to pay attention to this preview.
Patrick,
Yes.
with just VPC and more, and then she said that you'll guide us for VPC only, so that you can customize.
Oh, so that you can customize.
Yeah.
That's what you did.
Yeah, we did VPC and more.
Kwani, I had chewed. Just a second. Let me see the purpose of this lab. Create additional subnets. Did you create subnets?
Yeah,
You created
automatically though.
No, automatically. Oh, yeah. Okay. Good. Yes, Musembi, you are right. But now what we will do, because if I go with VPC only, this is when you just want to create something really quick. This is when you want to create something really quick. I will repeat the same process that Joy did, but now the difference between what we are doing and what you guys did in the morning is the fact that now here we are going to customize everything. We are not going to use whatever has been provided. Like when it comes to subnet, we will not select the subnet that has been provided. We will create our own. That's the goal. The goal is to help you guys know how to create your own, not use what is provided. Does it make sense? Done.
Yes. Yeah.
It makes sense? Okay.
Yeah.
Good. So let us go with VPC and more. And thank you for that. So we are going to change a few things here. Okay, this is just for tags. Tags are good. Let me tell you, as an engineer, you should learn to use tags, and we'll be talking about tagging at some point in this course. So we'll talk about that. But for now, I'll just leave this as it was. Let me just say this is VPC and more. That is the tag that I want to be applied. Then the CIDR range, you can see our CIDR range here is 10.0.0.0/16. And when we were talking about this during that other time, you saw the number of VPCs that the number of IPs that can be accommodated in this range. That is 65,000. And then for this is not important. We leave it as is. For tenancy, we leave it as is. We'll talk about it later. But now in our instruction, we are told that it is supposed to be single availability. So single availability, will change this to 1. Are you seeing that? We'll change this to 1. Okay. I wish this screen was bigger because there's something I wanted you to see. Can this move? None of this can move. Oh. I wanted you to see this schema. There's a very nice schema that is on this side, but let us do this first, then we'll find a way of doing that. So availability zone, so we have said that we need one availability zone. Okay, then, we've been told to uncheck this. So let us just uncheck. Let us follow the recipe as is. IPv4, we are told to enter 10.this.this. This is already there, so we're not going to change anything there. For IPv6, choose no IPv6 CIDR block. So that's already chosen for us. For tenancy, choose default. It's already chosen for us. For number of availability zones, 1, we've just done that right a minute ago. Number of public subnets, so we'll also have 1 public subnet, okay? And then 1 public subnet. Let me show you something. If we were to have like 2 or 3, you see, as we add, the number of public subnets is also being added here complementarily. Okay? So we'll have 1 public subnet. Private subnet will also have 1. Expand, customize, subnet CIDR block. So this is it. You're going to expand this. And then look at this. You are told public subnet CIDR block in US West 2A. US West 2A here, we need it to be /24. So we are going to change this to /20. Before I change it to /20, you can see we have 4,000 IPs, right? You can see that we have 4,000 IPs. So if I change this to 24, let's see what we get. We get 256 IPs. We don't need the 4,000, so we are reducing it to this. And this, it falls within our mask. It falls within our CIDR range for the VPC. So we have a /24. All right. Then for private, we are told it needs to be 10.0.1.0/24. Are you seeing that? It's similar as the above, but only that we have a difference here, 0 and 1. So I'll copy this as is. Then I'll come and paste it here. Okay. Now, NAT gateway. For NAT, we are told choose the number of availability zones in which to create NAT gateway. A NAT gateway is very expensive, so you need to be careful and you need to know where to provision it. So we are told here that we put it in 1 availability zone. So that's what we will choose, 1 availability zone. Then VPC endpoint, because we are not using any VPC endpoint, we will select none. Okay, we'll select none. Okay, then on the preview plane, name the resources as follows. On the preview plane. So I'll have to find a clever way of doing this. What will I do? Because this is the preview plane. Okay, so what I'll do, you will not be able to read this with me, but I'll be reading it and you'll just be listening. And if you've opened it, lucky for you, because my screen is small. I have no way of doing whatever needs to be done. So let us now edit this. This is the preview screen. This is the important one. Now we are being told, where are we? Just a second. Yeah, on the preview plane, that's number 8 of task 1. And name the resources as followed. For VPC, make sure it is called lab VPC. So this is our VPC. So we can add here lab, let me see, VPC, and then subnets. We have 2 subnets. For public subnet 1 without name tag, public subnet without name tag, this upper one, we are going to name it as public subnet 1. And again, copy it, and I just come and paste it here. So that's how we are supposed to name it. And then private subnet without name tag, which is the second one below it, we will name it as private subnet 1 here. Paste. Okay. Then we move. Okay. Then for the route tables, we have 2 route tables, as you can see here. For the route tables, this is what you are going to do. First box for public subnet without, see, just a second. Public subnet, public route table without name tag. We are going to use public route table. That's what they are saying we include here. I hope you guys are following. You are seeing. Then the other one, it will be private route table. You see? Paste. Good. Then we move on. For network connections, they are saying we leave it as is. Then choose create VPC on the screen and success message is displayed. So we are going to select what? We are going to choose create, not select, create VPC. And now you have a list here of what is being created. You see, all of those are what we call the VPC components, and they are being created. And you can see they're being created very fast. You can see they are being created very, very fast. So we
Hello,
wait.
Patrick.
Yes.
Can you do the preview again one more time? Sorry.
Ooh. Ah, la, 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 la. Mhm. Okay, I will explain it. I can actually not go back, sadly. Once I've clicked on create, I cannot go back. But where are you at? Were you following? As in, were you doing it at the same time that I was doing it? Sharon.
Yes, I was. I'm on the preview, so I'm
Mhm.
still there. I don't know
Oh,
what.
okay. Good. Are you in a position to share your screen? Then I can guide you. We can use you. Ati, I'm running. Okay, I think it appears like I'm running because okay, Paul. Maybe it's because
Yes,
I've
you
done it
are.
over and over. I'm sorry. I'm so sorry. But it's fun. It's fun. And I pray that one day you guys will be as runful as I am. Oh, guy. Okay, all right. Sharon, kindly share your screen. Then I'll take you guys Paul too.
Permission.
Oh, permission. Let me see. Am I the one that's supposed to give you permission?
Patrick,
Yes.
on the preview part, I can't really edit.
You can't.
Darling, mtu
no,
ana
like
scroll aje hii kitu?
Hmm?
Nataka kuscroll hadi mwisho.
Wait small. Ngojeni
Oh.
kidogo. Mhm. Let me just see something. Just a second. Sorry. I wish I saw your message, Sharon, before I clicked create. It would have helped us.
Same, I also can't edit.
Stanley,
But try sharing your screen. Are you able?
yeah,
Sure.
let me do that.
Okay.
Host disabled attendee screen sharing.
Okay, just a second. Mhm. That is Sharon, right?
Yes.
Mhm. Mhm. So apparently I also cannot share my screen. At I'm runful. It reminds me, I used to have an instructor who is my friend to date, the one that was my channel
Abraham
lead.
ninamwambia hivyo.
He used to
Angengoja
rap.
Salo. Angengoja tu Salo aende.
Sharon, you will burn. Sharon, you will burn. Unatuambia hapo na Salo na vile watu wamesota.
Patrick,
Yes.
I can't really edit.
You can't edit because of why I'm wondering.
I don't know. When I tap on it, it doesn't do anything. Like I can't edit.
Is it possible we just give you guys we give
Same to me.
you
I also can't
because
edit.
it is easier for me to know your problem by me seeing you doing it. Maybe, yeah, it would have been easier for me to see. Is it possible for any of you to share their screen?
Patrick, who wants to share the screen? Who's sharing?
Oh, actually we have, let me see. Let us start with Sharon. She was the first, and then was that Abby or Amy? And Belinda, in that order.
Sharon
Yeah.
Award. Amy.
Yes. So let us start with Sharon. Then after Sharon, we'll check Amy.
Where is this Sharon?
Sharon, I hope you're still in the call.
Yes.
Okay, Sharon can now share.
Okay, share your screen, we see. And maybe as we sort your issue, we might actually in the process also sort Amy's and Belinda's, but let us first try and see.
Patrick, unakimbia unaacha warembo wote nyuma.
Pole kwao. Tutajaribu kuwapeleka pole pole.
Hatujazoea relays polepole.
Tutaenda pole pole, aste aste. There is no rush. All right, so this is Sharon, right? Sharon?
Yes.
Oh, okay. Okay, let us go back to that screen. Click on Create VPC. Okay, then you need to select VPC and more. And for that, okay, let me just check the task one, making sure that everything is good. So, IPv4 CIDR range. Are you there? That's 20. Go back up. Dog. Yeah, so that IPv4 CIDR range. So the IPv4 CIDR range needs to be 10.0.0.0/16, not /24, /16. Good. Then we go down, we leave everything as is. Availability zone, we are using one availability zone. Okay. Then for public subnet, number of public subnet is 1. Number of private subnet is 1. And then customized subnet CIDR ranges. So for public subnet, CIDR block for US West 2A is 10.0.0/24. That is okay. For the private, it's also okay. That's exactly how it is supposed to be. Then NAT gateway, we choose one availability zone. One availability zone, that is okay. Then for the VPC endpoint, choose none. None, not S3, none. And then you are good. Up to there, we are good. Up to there, we are good. Okay. The ones that I had left behind, have you caught up? Are we good now? Up to there?
Yes.
Yes. Can I ask on the private?
Wait first, let me laugh small. Yani, it was the ladies that don't come back in you mouth. Okay, so I've not had any yes. Okay, good. Okay, please ask. Was it Amy speaking? Am I audible?
Yes.
Oh, so someone was asking something. Who was it? Because I want
Belinda.
us. Belinda, are
Yes.
you now good?
I was asking on the private subnet CIDR ya pili ni 10.00. The zeros ni mbili.
It's 10.0.1. Remove 10 there, Sharon.
Oh.
10.0.1.0. You remember what Jay taught us about the quartets? Was it quartets? Quartets. 1, 2, 3, 4. 4 times. Yes. So that's how it's supposed to be, okay? We are good. We are good up to there.
Yes.
Okay. Anybody else that is behind? Cool. So I assume that you are all good. Now, going to the preview. So click on the VPC name, the one that is written Project VPC. Click on that. Just a second. Where are we? Just a second.
Yeah, mine is also like that. Like I can't really edit. Nikitap inaleta hivyo.
Mbona inajiita Project VPC?
Hadi yangu.
They didn't turn off the suggestion of the...
Oh, yeah. Turn that off, the auto-generate bit. Turn that one off. Yes. Yeah, that was the problem. Thank you. Who is that gave us that solution?
It's me.
Yeah? Who was it? I cannot see my screen. Okay, you did well. You did well. Yes, yes, yes. That was the issue.
It was Justin.
Justin, thank you, Justin. So, guys, I hope that has been solved across for everybody. Once
Yes.
you uncheck that one comes there. So let us start by giving this thing names. So for the VPC, you are supposed to call it lab VPC, capital L, lab space VPC in capital. Good. And then we go to the subnets. The first one, you will call it public subnet 1, P and S capital. Public subnet space subnet space 1. Then the other one is private subnet 1. And then we move on to the route table. So the person that was asking how to move, that's what you use that slider. Then for the first one, you will name it as public route table. PRT capital, public route table. Then the other one, you will name it as private route table. Good, and then the rest you leave it as is. Then teremka chini, go down and click create VPC. Just go down, down, down. Yeah, click on that create VPC. Then you'll see that list. So guys, are we good up to that point? If you are good, let me see thumbs up. If we are good up to that point, let me see some thumbs up. Don't unshare, don't unshare. Cool, cool, awesome, awesome. So after the VPC is created, you will now be able to create additional subnets, then associate the subnets and add routes. And then we will be able also to create VPC security groups and launch a web and launch a web server instance. Let me check time. 57. We like 3 minutes to 4. Okay, good. All right. So good. Good. So yes, Sharon, you can just unshare. Thank you for that. Thank you for that. That was good. That was really, really good. That was really good. I hope you guys have seen that first step, how it is done. It was just like that. So Amy and Belinda, I believe that we are all okay, right?
Yes. Yes.
Okay, good, good. So, so I want to do these other steps, but I hope I'll not run. I hope I will not run. So Esther, give me back the share permission, the share privileges. I want to do these other points. So even if I eat into the, okay, thank you. We're waiting. Oh, still waiting. Okay.
Patrick, done.
Okay. Okay. It is sharing. Good. And as you can see, my VPC has been created. So I have a VPC. You see, I have a VPC. So I can go to view my VPC. Sorry. As you can see, this is the preview. This is the resource map. The preview that we were seeing is this resource map. You know, this is the resource map. So we are good. Okay. Awesome. So my VPC is there. It's called Lab VPC. You know, it's called Lab VPC. So the next task number 2, is about creating additional subnets. And in this task, you create 2 additional subnets in the second availability zone. You understand? This option is useful for creating resources in multiple availability zones to provide high availability. So in the left navigation plane, this one here, in the left navigation plane, choose subnets. So we are going to choose subnets, which is here. Click on it. Okay. So we have chosen subnets. Now, to configure the second public subnet, we are going to choose create subnet here. You see this one, click on it. When you click on it, you are told for VPC ID, this one, we come here and we select our VPC, which is Lab VPC. Select it. Good. Then for the subnet name, we are going to enter public subnet 2. So subnet name, you know, subnet name. So the associated CIDR is the same one that we had set when we were creating the VPC. It was /16. So subnet name, come here and you just paste the name provided in the lab as public subnet 2. For availability zone, you have a choice of either choosing a specific availability zone or leaving it at no preference. So we will leave it at no preference. Okay, that's the instruction. Then IPv4 CIDR block. IPv4 CIDR block. We are given as 10.0.2.0/24. So that's what we are going to enter. Okay, here we are going to change this to what has been given. Let me see, IPv4 CIDR block. IPv4 subnet. Subnet, sorry, not VPC, sorry. I almost did my own things. There you go. So that's what you enter there. Okay, then they say choose create subnet. You choose create, so you leave everything as is and you come and choose create subnet. Okay, subnet is getting created. So this is our subnet. It's now available. We are good. To configure the second private subnet. Now this is our public subnet. Now we need to configure the second private subnet. Same steps. Click on create subnet. Then after you've chosen that, the VPC ID is the lab VPC. And please be careful when you're choosing VPC, because if you create resources with the wrong VPC, you will have problems. Okay, avoid it by choosing the right one. Subnet name, we will call it private subnet 2. So that's our subnet name, private subnet 2. Okay, availability zone, again, no preference. And then IPv4 CIDR block, we have 10.0.3.0/24. I hope you guys are seeing how these numbers are not interlapping. Interlapping, is that really English? Overlapping, sorry. They are not overlapping. So one was 10.0.1.03. Another one was 10.0.2.03. Then we have 10.0.3.0/24. I don't know what I've said there, but yes, that is it. So make sure that they don't overlap, and then you create your subnet. In terms of creating subnets, are we together? If we are together, let me see some thumbs up. In terms of creating our subnets, are we together? Let me see some thumbs up if we are together. Good. Thank you. Thank you, guys. Thank you, guys. So we have created those subnets. Okay. We have created those subnets, and you can see our .3 is here. You see? And then we have our .2 here. And then the ones that we created earlier, 1 and 0, are also up there. So you see, they all have their own IP ranges. They all have their own unique IP addresses, not IP ranges, IP addresses. So I hope that is clear. Task number 3 is about associating the subnets and adding routes. Associating the subnets and adding routes. So in the left navigation panel, this one, we are going to click on route tables, this, just below subnets. Click on route tables. And then we are going to, okay, I've clicked on route tables. Okay. Then in the public, choose route table, then choose public route tables. Do we have public? Okay, this has not been distinguished into private, public, and private. Just a second.
You can refresh at the top.
Here.
Yes.
Let me see if we'll have them. Yeah. Oh, thank you. Thank you. So we are supposed to choose our public route table, this one, which we had created at the beginning. Okay. You remember our schema. Then in the lower panel, choose subnet association. This here, subnet association. Click on it. Okay. Then under subnets without explicit association, choose edit subnet association. So under this, we choose edit subnet association. Edit subnet association. Click on that. Good. Then select the checkboxes for public subnet 2. So we have public subnet 2 here. I think it's 1. I wonder why they're saying checkboxes, but that is it. Then choose save association. You click on save association. Okay. You now configure the route table that is used by the private subnet. So the same thing that we've done for public, we'll do for private. So choose private route table and choose this, and then we choose the private route table. Then choose subnet association. So subnet association is here. And then edit subnet association is 1. And then select checkbox for private subnet 2. So checkbox for private subnet 2, which is here. And then after you do that, you save association. Good. So that is that. Okay. That is that. So we've done that. Your VPC now has public and private subnets configured in 2 availability zones. Just like this image here. This is the image that we've just achieved. This is what we've achieved. We have two availability zones. And so that is what we've been able to do. Yeah, we are unchecking the first subnets because when you are doing the associations, when you click, it is just the same way that we were doing when you are launching the servers. When you click a server, the information you see down here relates to that server. So when you are trying to do the association, we want to associate it to the right subnet. That's why we uncheck one of the subnets that is automatically checked, and then now we associate the right one. If you left both of them ticked, then the information that we'll have here and even the subsequent association will not be the right one. No? You understand? Okay. Awesome. So, that question is important. That question is very, very important. Let me check something. Let me check something. We might have errored somewhere. Where is that? This one. Let me check this association, subnet association. Yeah, you see, both of them are associated with that. Yeah, so we did not error anywhere. Both of them are associated. Doesn't mean that when we were doing this and then we unchecked this when we were doing this, it's because we had already associated this. You don't deassociate just simply by unchecking here. When you're doing association and dissociation, you do one at a time. That's actually the logic behind it. Okay? That's the logic behind it. I hope that one makes sense. I hope that one makes some sense. So where is my, 1 second. Let me return this one to my secondary. I'll just be reading as we continue. Okay, so, so we've done that. So we are at step 4 of 6. Sorry, time is really running, but let's just do this. When you get out of this, you'll be able to do this one by yourselves very, very fast. Create a VPC security groups. So the next step is creating a VPC security group. And in this task, oh, lolo, somebody did not remind me to restart my lab. Oh, but we still have a lot of time. But let me just start. It will be very unfortunate to be kicked out after you've done all that. Okay, my lab is ready. My lab is ready. Okay, so create a VPC security group. In this task, you create a VPC security group which acts as a virtual firewall for your instance. When you launch an instance, you associate one or more security groups with the instance. You can add rules to each security group that allow traffic to or from its associated instances. Okay? So a security group is just a virtual firewall. And in the left panel, we are told we should select security groups. So in the left panel, this is the panel. We look for security groups, and this is security groups here. Under security groups, click on it. Then now that we have clicked on that, choose create security group up here. Create security group. And then configure the security group in the following option. So the security group name, we will call it security group. Okay, we'll call it security group. Copy, paste it here. That's the group name. And then under description, we will say, we'll call it enable HTTP access. Someone remind us HTTP, which port were we using for HTTP access? Was port number? Oh, that has not copied. Port number 80. Thank you. Thank you. I can see you guys remember. That's good. So we copy this. We come and paste it here. And then for VPC, we choose the right VPC. That's our lab VPC. Remember? Okay, good. Then under inbound rules, choose add rule. Inbound rules, we click on add rule. Then configure the following options. Under type, it will be TCP. No, sorry. Under type, it will be HTTP, not TCP. HTTP. So you see all these are different types. So you choose your HTTP. Here it is, HTTP. And then source, you choose anywhere IPv4. Source, we want to allow traffic from anywhere IPv4. Okay, so this is from the internet. That's why you see 0.0.0.0/0. And then for description, we write permit web requests. For description here, we write permit web requests. That is important. And then choose create security group down here. So we choose create security group. And that security group is being created, and it has been created for us. Okay? So that is our security group. That's our security group. And sometimes, Okay, we did not have a real name. I'm going to name this. Let me just name it. Naming helps because there will be time that we'll need to do association. So I'll name it as Web SG for Web Security Group. Naming does not really add or minus anything. I just want it there for identification so that we don't get mixed up when we are trying to find it among the other security groups. So task number 5 is to launch a web server instance. And in this task, you launch an EC2 instance into the new VPC. You configure the instance to act as a web server. So on the AWS console in the search bar, enter and choose EC2. So this was the VPC console. So we want to go back to the EC2 console. So EC2. So we choose EC2. This one you're familiar with. Then in the left navigation panel, we will choose instances. Let's wait for it to load. We will choose instances here. Cool. Cool. Okay, we'll choose instances. Then once we have chosen instances, choose launch instance and configure the following option. So we will choose launch instance. You can choose this or that. Let me go with this. It's still the same. Choose launch instance, and then you've been given some parameters to use. So in the name and tag section, name it as Web Server 1. Web Server 1. First of all, let me see, by confirmation through thumbs up, how many of you are with me where I am? I'm in task 5. How many of you are with me, either watching and understanding or you are doing it? How many of you? Let me see some thumbs up. I might be running and I think that I'm going. Brian, thank you. Sharon, where are you at? Are we good? Belinda? Yes,
Yeah, I'm
Sharon.
good. I'm good.
Ah, good. Belinda?
good.
You're good.
Good.
Amy? Amy? Where is Amy? Amy is not saying nothing. Purity?
I'm good. I'm good. I'm good.
Oh, you are good. Okay, awesome. Purity, are you good? Clinton, Tony?
No, I'm left behind.
Where? I told you should not be left behind. You should be talking. Where are you left at?
I'm at creating security group.
You are doing it right now.
Yes, I'm not seeing the option of creating security group.
Okay. Please stop me. Msiniache niende. If you leave me to go ahead, I'll not know what is happening because we're almost done. Esther, can you do us a favor and allow Purity to share her screen? Because this is very crucial, guys. This is very, very crucial. That's why I'm taking this time. And you see why we encourage you guys to be joining via your machines so that you will be able to do these things as we are doing. Don't join the
Purity and
sessions.
DC.
Yes, Purity and DC. Just bear with us, kidogo, guys. We're almost done, eh?
Purity, are you in a position to share now?
Purity, try.
Yes.
Okay, share your screen. We want to see. Yes, so you are the security group. Okay. Able, close that banner. Close that banner. No? Yeah. No, I meant this green thing. It has an X apogee. You see that X? Teremka chini. Just calm down. Calm down. That green thing, written security group, SG, blah, 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 was created successfully. There's an X. Are you not able to see this X? There's an X. Just calm down. Calm down. One step down. Yeah, that one. Click on it.
I click there.
Yes, click that. Okay, good. Then go back to the hamburger menu, the one that you closed the first time. Yeah, click on that. Then click on what are we trying to create? Security groups. Scroll down and find the security groups again. Just scroll down. Click on that security groups. There it is. Create security group. So you've seen it now. Then now every other step is just the same way that we said. You're good?
Yes, thank you.
Okay, cool. You're welcome. So work on that. Just follow. You have the how do you call it? You're just one step behind us, but you have everything that you need in terms of the write-up for task 4. It's very short. So you'll create that security group and then you'll be good. Okay, sharing back to me, please. Good, it's back. Thank you. Cool. So that was good. Thank you, Purity, for that. And thank you, Esther, for coordinating. So we want to, so that was the security group that Purity is creating. So Purity, you will be able to catch up, I believe, because we are just doing the last step. So should you not be able to navigate, I'll come back for you. But let us do this last step for the sake of time. Task 5, launch a web instance. So we are saying that in this, we are supposed to search EC2, which we have searched and it has brought us here. And we've been told that the name of our instance should be web server 1, as you can see there. Okay. Then in the application and OS images, we choose the Amazon Machine Image, AMI. We are supposed to go with Quick Start and pick Amazon Linux. This is what you've been picking all along. Okay. And I told you that there are other AMIs that you can use. There is macOS, there is Ubuntu, there is Windows, there is Red Hat, there is SUSE Linux, and Debian. And you can browse and even find even more. You understand? So that is that. So we will stick with our Linux because that's what they are saying we use. Then, Amazon Machine from the drop down. Choose Amazon Linux 2. In the application and OS image section, configure the following. Quick Start, choose Amazon Linux, we have it. Then Amazon Machine Image here under AMI, we are supposed to choose Amazon Linux 2 AMI. So let's see if it is different from what we have. Amazon Linux 2. Let's see. I think they changed that because this instructions is a kitambo. Amazon Linux 2, Amazon Linux 2 AMI HVM. Amazon Linux 2 AMI. Nope, we will stick with what we have here. It must have been updated because again, I told you that these things were written back in those days. Then in the instance type, choose T3. I need to get out of this. Choose T3. So where is our instance type? We drop down T3 micro. It's already chosen for us, so we will stick with it. T3 micro. In the key pair, you see choose Voc. So there is a key that we are supposed to get already created for us called Voc. So let's see. Here it is, Voc. Click on it. So that's the key. Okay. Okay. Then in the network settings section, choose edit and configure the following options. So we edit this and then we start with our VPC. For the VPC here, we will choose lab VPC. Okay, lab VPC. That's good. For the subnet, we will choose public subnet 2, the one we created. Public subnet 2, this one. Click on it. Those are the rules. Okay. So that's where our instance will be created. Then for auto assign public IP, choose enable. For auto assign public IP, choose enable, and then firewall security groups, choose select existing security group. So for this, we will say select existing security group. Okay. Then we are going to choose our web security group. Remember our web security group? So here is our security group. This is our web security group, the one we created. Okay, so that's what we are going to choose. And then expand advanced details. So the advanced details are down here. We'll expand this. Okay. Then under user data, copy and paste the following code. So there is a code to create an HTTPD server. There's a code, rather user data, that you're going to put inside here. You see where we are putting it? User data. So we are going to paste that here. That is the code. I've just lifted it as is. Then they say here, choose launch instance. So we are going to launch this instance. This is it. Launch instance. Okay. So we are launching the instance. To display the launch instance, choose view all instances. So we'll come to instances. And then here is our instance called web server. You see, still initializing. Okay. Wait until the web server 1 shows 2 out of 2 checks passed in the status check column. I think it's even going to show 3/3. They must have changed a thing. They must have added a parameter. So this might take a few minutes. So let us just wait for it. Yeah. So let us just give it a second. We keep refreshing as we wait on that. So question. Are we good up to there? If you are with me up to that point, please let me see some thumbs up. If you are with me up to that point, let me see some thumbs up. Thank you, Brian. Thank you, Tony. Thank you, Frank. Thank you, Belinda. Thank you, Abby. Thank you, Naboth. Good. I like it. I like it. I like the fact that you guys are following. This is a very important step. And there are so many people who don't know how to do that, and yet they have some certifications with them. You know? So this is a very, very important first step for any cloud engineer, because when you'll be provisioning these things, you will need to know how to do that. That's very, very important. Belinda, you're laughing. Yeah. Laugh. It's true. It's true. It's true. This is the starting point for everything. So once you guys know how to do that, it makes life a bit easy. Let's refresh again. I know it's taking time because of the HTTPD, so it is still doing a few of those stuff. So we give it a few. So you see, you can already see that we have our public IPv4, we have our private IPv4, we have our DNS, you know, we have our host name. Okay. See, we don't have an elastic IP associated to this. So we have our instance type as T3 micro, you know. Okay. So this is very, very good. This is good. So we wait for this to finish. Then we do one check and then we'll be done. That was important. So what I'm thinking is because I've eaten into your group work time, why don't you guys just take a break? Because again, getting out of this and going into group work, you'll be, I think you must be exhausted. It's good that you take a break, rest. And this particular lab, you can actually do it singly. You know, you can do it because I've actually done the whole lab for you in class. So you have no reason to get stuck. So try it on your own. And then Should you get stuck, then go to your groups and ask people from your group. And should it be a group-wide problem that you guys don't know what to do, you can now reach out to me and I'll be able to help you. That is from both Kenais. If you feel that you are thoroughly stuck, I can then be able to help you. But I want you guys to try it out because I've shown you what you're supposed to do, and the instructions are also very direct. I've just been following those instructions word for word. Let's try this again and see. There goes. See, we have 3 out of 3 checks. So our checks are good. Now, what are they telling us to do next? So this may take a few minutes, has taken actually a few minutes. Then select checkbox for the instance as we have selected and choose details. So this is the details that we are supposed to choose. Copy the public IPv4 DNS. This is now, it is called time for truth. So copy that. Then open a new web browser and press the public IPv4 and press enter. Okay, let us see what we are going to get to. Okay, enter. Site cannot be reached because of why? Taking too long. Give it a second. We already allowed HTTP, yes? We allowed HTTP, so give me a sec. Just a second. Refuse to connect. US West 2. Refuse to connect because of why? Troubleshooting caps on. Why is it refusing to connect? Who is that that likes laughing? Why is it refusing to connect? Just a sec. Who? Me? I like laughing. Oh. Oh, Belinda. Oh, it's not me. Okay. Well, I've wondered. Okay. Laughter is good. What could be the reason? Okay. Anyone with an idea why it's not connecting? Or has anyone that is following, has yours connected? Because we have allowed port 80. Let me check the security groups, just a minute. Security. Okay, 1 second. So we have Knuckles. We had Knuckles somewhere. VPC. Let's open it on a different tab. Let's look at the Knuckle network access control list. Where are you? Sometimes you're normally the culprit. Let's see. So we have our Knuckle, 2 inbound, 2 inbound, that's inbound, 2 outbound, 2 outbound. Where is our Knuckle? Our Knuckle is this one for Lab VPC. Let's see. Why is it denying traffic and allowing at the same time? Edit this. And this is inactive, so it should not be an issue. Yeah, that is inactive, so it should not be an issue. So rule number 100, all traffic. Okay, but remember what I've done, HTTP. So let me just change that one to HTTP. Port number, the port number is 80 Musembi. Port number is 80, save changes. So I've updated that. This is not in effect, and why is it still there? But anyway, so let me try and see something here. Well, it's taking forever. It's refusing still. One sec. So when you're troubleshooting, this is what you do. If you change something and it fails to work, you change it back to what it was. And what was it? It was all traffic. Okay. Save changes. Our security group is also not the problem, I believe. Security group. So our security group is not the problem. This is it. This one. Let's see inbound rules. Where are the inbound rules? Just a second. So WebSG, you see the port is port 80. HTTP is port 80. HTTPS is 443. Permit web request, that is the thing. Outbound, did we have any outbound rules? All traffic to the internet. Okay. Just a second. Another culprit is normally the route tables. Let's look at our route tables. Just troubleshooting to make sure that everything is okay. So public route table. Let's look at your associations, subnet associations. So public route table. That's okay. What are the routes like? To the internet, to local, route origin, create a route table. That should be working. So we have our route table. Our route table iko sawa. Yeah, our route table is okay. IGW. So internet gateway. This is attached to our Love VPC. So Love VPC has internet gateway attached. So what could be the issue? Okay, give me a sec. Let me do something here. I'm not able to use Q. Okay. So everything we did it by the book. We have put everything where it is supposed to be, but why are we still not able to connect? Okay, give me a sec. Okay. So that's our . So back to the instances. EC2, EC2. Just a second. Yeah, Salem, that's what I want to try using IP. But Justin is saying that it's also not working. Oh, Justin, you've already tried. Mhm. Okay, give it a second. I hope this is not one of those labs that has problems again, because we have just come from Linux and we had a lot of problems in the Linux labs. Hope this one does not. I was hoping this one would work bila shida without any problem. Just a second. http:// Okay, let's see. Refused to connect. So just a second. Don't worry. Don't worry. Even if they have problems, we'll figure out. So let's try this and see. So okay, so this one, I hope they'll allow us to connect via Instance Connect. Please allow us connect via Instance Connect. Please. I want to check something. Unable to connect. That's not, these are now things that I don't want to see. Okay, these are now things that I don't want to see. Okay. The problem might be as yeah, we have insufficient permission. That's true, because again, they only allow you to use what you can use, what has been allowed. Now, I'm not sure how long it will take me to do it, but I'm going to do it, not in class, after class, but I wanted someone that is willing to do it. Maybe let us try. You see the place where we used the key that was provided, the voc key. Instead of using the voc key, create another key, create another key and then try. And let us see if the problem originates from there, because everything else is okay. Everything else is there. We've checked the networking is okay. The security groups are okay. Yes, the security groups are okay. So try that. And then if you are successful, just inbox me and tell me that you're successful. If you're successful, what we will do, we are likely to do, okay, I can, yeah, we'll find a way of repeating the lab tomorrow. The whole lab tomorrow now with the right steps, because again, now troubleshooting in a live class is kind of difficult. So we'll try and do that. But the problem is not you. The problem must be with the lab, because everything, we followed everything step by step. So maybe by tomorrow's morning class, I'll have figured out the solution. And if anybody else finds a solution before then, just let me know. I hope that's agreeable. I don't want to keep you here for longer. Is that agreeable? If it's agreeable, let me see some thumbs up. Some thumbs up. Thumbs up. Good. Awesome. Cool. So we are going to let us try that one on the side, and then we will come back and see what we can do about it. Yep. So let me end the recording here so that it does not become overly long. Just a second. Let me stop recording.